Morning students. So today we are going to start a new topic, that is alternating current. Though we have discussed many things about this topic in 10th class also, but basic terms are there which are new for you. So just let's start. We are having two kind of current, that is direct current and alternating current. In both the current there is flow of electron, that we know very well. But the difference between the direct current and alternating current is that in the alternating current it varies like sine function with the time. The non-medical student, if you have done sine curve graph, we know it is like that. Same is the trend for the alternating current. Alternating current also varies with time, means its frequent, there is particular frequency in the alternating current, but in the direct current there is no frequency. So there basic difference between the alternating and the direct current is upon frequency concept. We can see that this is a sine curve, and we know that this is called the frequency. Number of times waves are repeating number of times waves are repeating is called frequency. Here omega I have taken angular frequency, and t is the time during which the waves are repeating itself. And we have to give corresponding voltage also, by which the waves will repeat itself, which will derive ultimately which will derive the alternating current. So here we are having the graph for the alternating current. This is called the maximum value of the alternating current. These peak values are known as the maximum value, highest and lowest mean values, we can say this thing. And omega is angular frequency, t is the time. Suppose I have this circuit in which I have given cell, and when when the supply will be given to the cell, when the supply will be given to the bulb from the cell, it will start glowing. All electrons are moving in one direction. So this is called the direct current. Direct current means there will be no change in the direction, but in alternating current there will be change in the direction of the current. Here is a sign for the alternating current. So there will be change in the current and the direction as well, but in the direct current there will be no change in the direction. Two differences we have done. There is no concept of frequency in the direct current, but their frequency matters in the case of alternating current. If we will talk about the direct current, there is no change in the direction of direct current, but there is a change in current or direction in the case of alternating current. Here is a symbol for the alternating current, means it varies with time. So we can write the equation also for the alternating current as well as of given voltage. As I told you that alternating current means graphical representation of sine wave, sine curve. Current means when we are taking the mean value, I can write this mean value is equal to Im, maximum value. I is equal to Im. The curve is sine, and angle, how the curves are varying by this phase omega t, where omega is the angular frequency, t is the time. So this is our particular equation for the alternating current. Same we can write for the voltage, and in case of voltage I will change current parameters with the voltage. So I can write v is equal to vm sine omega t, because this voltage will derive the current only. So this is all about the concept of alternating current. Then next we are going to do very important term, that is RMS and the mean value of alternating current. You can see firstly mean value of alternating current, or I can say peak value of alternating current. What is the mean value? The mean value of alternating current over any half cycle. As I told you that alternating current varies with the time, so I am taking half cycle. Mean value of alternating current over any half cycle is that steady current means continuous current which sends the same charge, जहाँ पे हमारे पास सेम चार्ज आ रहा है, through a circuit in half the time period. As I have taken half cycle, so half the time period I will take only of alternating current. Then I am talking about the half cycle, so small amount of charge I can consider for it. the small amount of charge sent in small time dt. We know that current is equal to rate of flow of charge, that we know already, but here we are talking about the small amount of charge. So dq I can take as I dt in small time. In the last topic I told you the equation for the alternating current. So in place of I can write this equation. Time I am taking over half cycle. So while doing integration of dq, d will get cancelled with integration and q will be equal to I naught sin omega t dt. We know the integration of sin omega t is minus cos omega t divided by its angle, that is omega. Limits I am taking 0 to t by 2. Rest is the part of mathematical calculation that you know very well, because many times we have done the integration. So minus omega is constant term, we will keep it outside. And now what we will do, we will fill the higher limit minus lower. In place of t, because t is a variable over here, so t by 2 minus cos 0. Firstly, in place of t I put t by 2, then in place of t I put 0. Cos omega t by 2. We can write omega as 2 pi by t. Omega, that is angular frequency, 2 pi by t, or I can write 2 pi f. This thing we have done many times, that angular frequency is equal to 2 pi by t, and 2 pi by t is known as frequency. So in place of omega I'll put 2 pi by t, you can see over here. Minus I naught 2 pi by t, again here in place of omega again I will put 2 pi by t into t by 2 as this. So minus cos 0, t will get cancelled by t, 2 will be cancelled by 2, and we know cos pi, cos 180 is equal to minus 1. So I'll put minus 1, again minus 1, minus minus plus, again this minus will get cancelled with the outside minus, and I will be left with I naught t upon pi. Charge sent in t by 2, q is equal to it, we know that thing, we know q is equal to it, and we are taking that charge sent in time t by 2. So I can write this also, you can see this thing better. Q is equal to it, this thing we know, and I am taking time t by 2 over half cycle mean value. हाफ साइकिल पे वैल्यू मेरी यहाँ पे पहुँचेगी im, that is maximum value. So time over here t by 2, im t by 2. This is also q, this is also. I can equate both the equation. When you will equate both the equation, we will get this required result. You can solve also. In first I have I naught t by pi, in the second I have im t by 2. Now what can we do? T will get cancelled by t, and im will be 2 I naught divided by pi. So this is my value for the alternating current, mean value for the alternating current. And the next we are having the RMS value for the just see this thing better. Here we have derived for the alternating current, same will be for the alternating same will be for the EMF. Here we have derived current, same derivation will be for the EMF. The difference will be that only in place of terms of current we will put V, or in some books they have put epsilon. Both represents electromotive force, EMF only. So the next I have RMS value. I am giving you the one term only, that is mean value for alternating current and RMS value for alternating current. The next part of this is mean value of EMF and RMS value of EMF. That is almost similar, which you will do by yourself. So next we are having RMS, means it can be defined as the steady value of current which will develop the same amount of heat, means the value we are giving for the current and it will develop same amount of heat in a given resistance in a given time as is done by AC when passes through the same resistance for the same time. We know this equation, I is equal to I naught sin omega t. Many times we have derived the equation for heat. We know Joule's law of heating. In class 10th we have done this. In Joule's law of heating, H was equal to I square RT. Here small amount of charge, small amount of current means small amount of heat and in a small amount of time. So dH is equal to I square R dt. In place of I can put this equation, I naught sin omega t square R dt. Afterwards again the concept of integration. I naught square r I kept outside, and the formula for sine square omega t, we know 1 minus cos 2 omega t divided by 2 into dt. Now I'll separate the terms and do the integration. Now RMS value I'm taking, so limit will be 0 to 2. The limits will be 0 to, sorry, t, not to 0 to t. So I naught square r, by doing integration 1 by 2 dt, clear, it will become t only. 2 will come outside, 2 बाहर आ जाएगा. ओके, टी और साइन कॉस टू ओमेगा टी की इंटीग्रेशन माइनस साइन टू सॉरी ओनली प्लस साइन टू ओमेगा टी. अगेन व्हाट आई डू, पुट लिमिट्स कैपिटल टी, हायर लिमिट माइनस लोअर लिमिट, अगेन इन प्लेस ऑफ ओमेगा 2 पाई. ओमेगा की वैल्यू क्या होती है, 2 पाई बाई टी. हेयर आई हैव ओमेगा टी, सो डायरेक्टली आई विल पुट 2 पाई ओनली. So this term I naught square RT upon 2, because 2 will get cancelled by 2, clear. So I naught square RT divided by 2 only. Afterwards what we will have, we know that H is equal to I square RT. Again I will equate both the equation, and the RMS value for the alternating current we will get as I naught upon root 2. So this is all about the RMS value of alternating current. Very easy derivation. Still, if you will have any kind of doubt, query or problem, you can send message and I'll try to make it clear. Thank you.